All right, let's want to talk about a couple of things just to wrap up this section. The first of all, let's talk about function inverses. If a function, if you take a function and swap the inputs and outputs, all right. So here I've drawn a graph of like an arrow diagram for a function f from a to b. A is a, b, c, and b is 1, 2, 3. It goes A maps to 2, B maps to 3, and C maps to 1. If you mirror image that and essentially swap the roles of A and B, you can create F inverse, which maps from B back to A again. 1 maps to C, 2 maps to A, 3 maps to B. Okay, so that's basically what a function inverse is. It's just the function that undoes whatever F did, right? That's F inverse. So a couple notes about this. First of all, if F were not injective, then F inverse would not give like a well-defined output. So F has to be injective. So what I mean by that is if instead we tried to do this, I'm going to erase and sort of edit this slightly. If instead A was mapping to 1, right? If A and C both map to 1, then we're going to get rid of the 2. 2 doesn't map back to anything, right? Because nothing was mapping to 2 in the first place. 1 is going to map to C, but 1 is also going to map to A. This is a problem. You can't have an element in the domain mapping to 2 different places. So if you didn't have an injective function, then you'd have a problem here, because when you reverse the arrows and make them go the other way, you'd have one element mapping to 2 different places. So that's not allowed. We can't have that. So let's put it back. Let's put it back. Put it back. Undo that. Control Z. All right. Let's go back to having A map to 2 and 2 map back to A. All right. Note number 2. If F were not surjective, then F inverse would not be defined at all. So here's the problem with that one. If we had another element on the domain, or on the codomain down here, say we had an element 4, right? And so this maps over here. And then you have this other element, and it's like, well, hey, what's up with that element there? It doesn't get mapped to. When you try to do the inverse, here's that element. It's in the domain, and the question is, well, where does it go? It's in the domain now, because we swapped the domain and range, right? I misspoke. You swapped the domain and codomain. So when the codomain becomes the domain, now you have an element, and you don't know where it's supposed to go, right? So what does that map to? Well, it doesn't say. There's no rule to undo. So that's a problem. Then it wouldn't be defined. There wouldn't be a valid domain input. And so that can't happen. So F must be surjective. So what we've shown is that what I've kind of explained here is that F has to be injective and it has to be surjective in order for a function inverse to exist. So our theorem, to wrap that up, is that a function F is invertible if and only if it is a bijection. Okay. Technically, no other type of function is invertible. It has to be a bijection. Otherwise, you run into one of these 2 problems.